So in order to talk about functions, we need to talk about a relation. Oh, okay, thank you. We need to talk about a relation. So in order to talk about functions, you got to understand what a relation is. So a relation is just a set of ordered pairs. A relation is a set of ordered pairs. That's all it is. So I'm going to ask you this. Is number 10 a relation? Why not? A relation is a set of ordered pairs. Is number 10 a relation? What are these? Ordered pairs. Right? So these are ordered pairs. So when I graphed it, listen carefully, when I graphed it, all these points on here are ordered pairs. There's an x and a y coordinate. There's an x and a y coordinate. So is this what I'm pointing to a relation?
Yes.
Yeah, because it's made up of a set of ordered pairs. Is this a relation? Yes, it's made up of a set of ordered pairs. So all those lines that I've drawn are all those relations. Yes. Because when I drew the lines, I was plotting a set of what? Ordered pairs. Okay? So a relation set of ordered pairs. So everything we've done at this point has been a relation. Everything we've done. So all those lines that we graphed, all those were relations because they're made up of a set of ordered pairs. That's what you did. Now, let's talk about a function. A function is a special kind of relation. And here's the definition. For each x coordinate, there is only one y coordinate. For each x coordinate, there's only one y coordinate. Yes?
So the relation you just showed are those not functions.
Say it again?
I said, so the relation that you just showed are those not functions?
No, some of them are. There's one kind that's not.
No, the one with this, I'm gonna let you see.
Yeah, okay. So a function is a special kind of relation, and here's the definition. That's important. For each x coordinate, there's how many y coordinates attached to it? Just one. Okay? So for example, let's suppose we had y equals x plus 5. Y equals x plus 5. I'm going to do a t-table just to show you. So that's going to help you with understanding of this. If x is 0, what is my y value? 5. So when x is 0, how many y values did I have? Just one. What is it? 5. When x is 1, what's my y value?
6.
Was there any other y value when x is 1?
No.
No. It was exactly what? 6 though, right? When x is negative 1, what's my y value? 4. Because negative 1 plus 5 is 4. Any other y value for negative 1? No. So notice, when x is 0, see how many arrows you have? I'm only drawing one arrow. It's going to what? 5. When x is 1, I'm drawing one arrow. It's going to what? 6. When x is negative 1, I'm drawing one arrow. It's going to what? 4. So this is a function. So y equal x plus 5 is a function. So since for each x coordinate, there is only one y coordinate, y equal x plus 5 is a function. And if you go back to the t-tables we've done, we did in the previous class being the one before that, when we draw those t-tables, you'll notice for each of those x coordinates, how many y coordinates were there? 1. So all those were functions except for one. And let me explain which one it is. Let's look at x equal 3. That's a line, right? Is that a relation?
Yeah.
Yes, it's a relation. Because it's a set of ordered pairs. Because when I do this, watch. When I do this, that means that all my x coordinates are what? 3, no matter what y is, right? So y'all agree it's a set of ordered pairs?
Yeah.
All right, now let's talk about the definition. Definition said this. For each x coordinate, there was how many y coordinates attached to it? Just 1. But notice the only x coordinate here is just what number? 3. And 3 gets mapped to 0. What else? 1. What else? 2. And there's an infinite number, right? So when x is 3, is there only one y value? No. So that's not a function. So x equal 3 is not a function. It's a relation, but it's not a function. Okay? So we'll talk more about, I just wanted to introduce that. So we'll talk more about relations and functions the next class period. Some other things you're going to learn about relation and functions is that given a graph, you could use, and you may remember this, the vertical line test. Remember those words, vertical line test? No? It's okay if you don't.
Yeah, I do.
So you can use a vertical line test to determine if something's a function, if the graph is given. But everyone we've done so far has been a function except for what kind of line? Vertical line. A vertical line. And when we talk about the vertical line test, you'll see it a little bit better why a vertical line is not a function. But notice when x is 3, or x equal 5, or whatever it may be, you have an infinite number of y values for x. So it's not a function. So it's very important, though, that you know the definition of function in order to do the problems we're about to do. Okay? And so there will be some notation that we're going to use as we go through this. So functions are very important, especially next semester. Most of what we're doing here is not going to be dealing with functions. It's only the beginning of the semester where we talk about functions, but in college algebra, it's almost all functions. The notation, if you recall, the notation, see where I have that y equal x plus 5? And that's a function, right? There's a certain notation that we're going to talk about next class period, and that's the notation for y. So y, sometimes you can write it as, if it's a function, you're going to say f of x. Remember the f of x? Or it could be g of x, whatever letter you want to use. It's not always just f of x, and you're going to see that. It could be g of x, h of x, k of x, m of x, whatever. But that's function notation. It means the same thing, guys. This right here means the same thing as this. It's just a different way of writing something. Just like 4/3, another way of writing 4/3 is 1 and what? 1/3. They mean the same thing. It's just a different way. Sometimes it's easier with what we're dealing with to use a improper fraction. Sometimes it's easier to use mixed numbers. Same thing for functions. Sometimes it's easier to leave it as y. Sometimes it's more helpful to write it as f of x. It's just a different way of writing things, but you got to be able to deal with the different notations, just like it was necessary for you to be able to deal with different ways of writing numbers. Okay, so there's all some interconnectedness among these concepts. Okay? Say it again.
Is that the same thing if x is right there, the y is right? It would be f of x.
F of x, yes. So this f of x is the same thing as what letter? Y. G of x, same thing as what letter? Y. So we'll do more with that next class period. So I just want to introduce that because I needed to do something with functions this week. Okay? All right, so it's not difficult. Most students can handle the functions in this course. Now, next semester, the functions get a little bit more complicated because you have different kinds of functions. It's not always linear. It's not always quadratic.